Here we have an example. A 1000 kilogram satellite is put into orbit at 300 km from the surface of the Earth. Letter A, what is the speed, period, and radial acceleration of the satellite? And letter B, how much work is done in putting the satellite into orbit? For letter A, to find the speed, period, and radial acceleration of the satellite we use the equations shown here. First we solve for the velocity, or specifically the tangential velocity, and we obtain the value shown in equation 53. So the satellite moves about 7,000 meters per second. For the period we can use either of the two equations. First we have the one involving the gravitational constant and mass of Earth. After substituting the known values we see that the period would be around 5,000 seconds, or about 90.5 minutes for the satellite to move around its orbit. Using the other equation and the value of tangential velocity obtained earlier, we have that the period is about 5,000 seconds, also with a slight difference in seconds, but it is still around 90 minutes. So, either equation and values obtained are acceptable. But personally I would prefer to use the equation that is obtained from the given values in case the calculated ones might be wrong. For the radial acceleration, or also known as centripetal acceleration, we use equation 46. After manipulating the equation and substituting the known values, we obtain the radial acceleration, which is given in equation 55. For letter B, we find the work is done in putting the satellite into orbit by using the equation for change in energy as shown here in equation 55. Considering the energy at the surface where the satellite is initially at rest before being launched to space shown in equation 56. The kinetic energy at the surface would equal to 0 and only gravitational energy is present. So we can write that the mechanical energy at the surface of the Earth is given by equation 57, which is just the gravitational potential energy. For the satellite in orbit where it is moving at an elevated position, its mechanical energy is given by equation 58. Substituting the equations for this condition, which we have equation 59. Further simplifying the equation, we obtain an expression for the mechanical energy in orbit shown in equation 60. We then substitute the obtained expressions for the mechanical energies to equation 55. Further simplifying the expression, we arrive at equation 60, which is the work done in putting a 1000 kilogram satellite to this orbit.